Drop that. Give me that. So, I love it, love it, love it. So, you love it, love it, love it. Yeah, I'm ready. So, she's 88, 태어났지.
Hi guys! What are you guys doing now?
We are learning about grid computing, which contain in the first one is introduction,
And the second is grid computing. And the third is virtualization. And the last, MapReduce and NoSQL.
Ah, okay. Can you guys explain me about the topics?
of course. You can start by me. I will explain introduction to you.
Okay.
Okay, the first one is about computational theory. Computational theory is the branch of computer science and mathematics that discuss whether and how a problem can be solved on computational models using algorithms. This field of science deals primarily with regards to computability and complexity in relation to computational formalism. The second subject is implementation of modern computing in some of the fields that are really important in our world right now. The first one is implementation of modern computing in the field of economics. Implementation in economic science is the study of agent-based computational modeling, computational econometrics and statistics, financial computing, computational modeling of dynamic macroeconomic system, programming specifically designed for economic computing, and the development of aids in computing economics educations. The second one is implementation of modern computation in chemistry. Implementation of modern computation in the field of chemistry is computational chemistry that could be used to help solve chemical problems. For example, the use of supercomputers to calculate the structure and molecular properties. The third is implementation of modern computation in mathematics. Resolving a problem relating to mathematical calculations, but in the sense that will be discussed in the discussion of modern computing system that will solve mathematical problem using a computer by compiling algorithms that can be understood by computers that are really useful for solving human problems. The fourth is implementation of computing in the field of geography. Geography is the study of location and equation and spatial variation of physical phenomena and humans on the surface of the earth. Computing in geology usually used for weather forecasting, especially in Indonesia, in the one state agency with the name of BMKG. The fifth is implementation of modern computation in the field of physics. The implementation of modern computing in the field of physics is computational physics, which studies a combination of physics, computer science, and applied mathematics to provide solutions to complex events in the world, either by using simulation as well as the proper use of algorithms. And the last one is implementation of modern computing in the field of geology. In the field of geology, computational theory is usually used for mining. A computer system is used to analyze mineral materials and minerals contained in the soil. Okay, that was my part. We should continue to the next person.
The next part is you, isn't it, Tika?
Yeah, I think.
Give me the camera, please. Hi!
Okay, the next introduction is about cloud computing. Point A, cloud computing is a method from delivering information technology or IT service in which research and are retrieved from the internet through web-based tools and applications, as opposed to a direct connection to a server. Rather than keeping files on a proprietary hard drive, local storage device, cloud-based storage make it possible to save them to a remote database. As long as an electronic device has access to the web, it has access to the data and the software programs to run it. It's called cloud computing because the information being accessed is found in the cloud and does not require a user to be in a specific place to gain access to it. This type of system allows employees to work remotely. Companies providing cloud service enable users to store files and applications on remote server and then access all the data via the internet. Okay, next advantage of cloud computing. We have cost, speed, global scale, productivity, performance, and the last is reliability. And we have two disadvantage of cloud computing. Initially, security was seen as a detractor from using the cloud, especially when it comes to sensitive medical records and financial information. While regulations are forcing cloud computing service to shore up their security and compliance measures, it remains ongoing issue. Media headlines are constantly screaming about data breach at this or that company, in which sensitive information has made its way into the hands of malicious hackers who may delete, manipulate, or otherwise exploit the data. Maybe it's though, according to some report, most of the data breach have been with on-site system, not just in the cloud. Encryption protects vital information, but if the encryption key is lost, the data disappears. Next, we go to types of cloud computing. SaaS, PaaS, and last IaaS. Okay, it's about what my topic. Next, we go to other topics. See ya.
Now, I'm gonna explain the half of grid computing. Grid computing is the use of resources that involve multiple distributed and graphically dispersed computers to solve large-scale computing problems. Grid computing is a branch of distributed computing. The computer grid has a more prominent difference and is applied to the infrastructure side of the compilation of a process. Concept of grid computing. Some basic concepts of grid computing. First, resources are managed and controlled locally. Second, different research may have different policies and mechanisms, including computing research managed by different batch systems, different storage systems, and different nodes. Different policies are introduced to the same user or different research on the grid. Third, dynamic nature. Research and users can change frequently. Fourth, collaborative environment for a communicative or electronic community on the internet. And the last one, three things are sharing in grid system, among others, research, network, and process. The usefulness or service of the grid system itself is to perform high throughput computing in the field of research or other computing process that requires a lot of computer research. How grid computing works? According to a short article by Ian Foster, there is a checklist that can be used to identify that a system doing grid computing is: first, the system coordinates the computational research that are not under a centralized domain of administrative domains, then the computation cannot be said to be grid computing. The second is the system use standards and protocols that are open or not linked to a particular implementation or product. Grid computing is composed of agreements on fundamental issues required to realize large-scale computing together. Agreements and standards required are in the areas of authentication, authorization, research, and access to research. And the last one, the systems strive to achieve sophisticated quality of service or non-trivial quality of service that is far above the quality of service of individual components of the grid computing. Thank you.
So yeah, it's finally my part. I'm gonna explain to you guys about virtualization in cloud computing. So what is it about? Yeah, virtualization is the creation of a virtual version of something such as a server, a desktop, a storage device, an operating system, or network resource. In other words, virtualization is a technique which allows to share a single physical instance of a resource or an application among multiple customers and organizations. It does by assigning a logical name to a physical storage and providing a pointer to that physical resource when demanded. And what is the concept behind the virtualization? Creation of virtual machine over existing operating system and hardware is known as hardware virtualization. A virtual machine provides an environment that is logically separated from the underlying hardware. The machine on which the virtual machine is going to create is known as host machine, and that virtual machine is referred as a guest machine. And what is the type of virtualization? The first, there is a hardware virtualization. The second one is operating system virtualization. The third is server virtualization. Fourth, we have storage virtualization. And how does virtualization work in cloud computing? Virtualization plays a very important role in the cloud computing technology. Normally, in the cloud computing, users share the data present in the cloud-like application, but actually, with the help of virtualization, users shares the infrastructure. The main usage virtualization technology is to provide the application with the standard version to their cloud user. Suppose if the next version of the application is released, then cloud provider has to provide the latest version to their cloud users, and practically it is possible because it is more expensive. To overcome this problem, we use basically virtualization technology. By using virtualization, all servers and the software application which are required by other providers are maintained by the third-party people, and the cloud providers have to pay the money on monthly or annual basis. And the next topic is about distributed computing. What is it? Distributed computing can be defined as the use of a distributed system to solve a single large problem by breaking it down into several tasks, where each task is computed in the individual computers of the distributed system. And a distributed system consists of more than one self-directed computer that communicates through a network. All the computers connected in a network communicate. All the computers connected in a network communicate with each other to attain a common goal by making use of their own local memories. And the next distributed computing system example, there are first World Wide Web, or as we know, WWW, and social media giant Facebook, headless distributed file system, ATM, cloud network system, Google Bots, Google Web Server, and indexing server. To a normal user, distributed computing system appear as a single system where internally distributed systems are connected to several nodes, which perform the design computing tasks. Let's consider the Google Web Server from user point of view. When users submit in a search query, they believe that Google Web Server is a single system where they need to log into Google. Command search for the required term. What really happens is that underneath is a distributed computing technology where Google developed several servers and distributed them in different geographical locations to provide the search result in seconds or at time milliseconds. And what is the benefit of distributed computing? The benefits are distributed computing system provide a better price or performance ratio when compared to a centralized computer because adding microphone is more economic than mainframes. And the second is distributed computing have more computational power than centralized or mainframe computing system. Distributed computing system provide incremental growth so that organization can add software and computation power in increment as and when business needs. So yeah, that's all my part. And we're gonna continue to Cynthia's turn.
So, I'm the last part, and this is my topic, MapReduce and NoSQL. Reduce and NoSQL is a framework programming to help users develop a large size data that can be distributed to each other. MapReduce is one of the most important technical concepts include technology, especially because it can be implemented in a distributed computing environment. Thus, it will guarantee the scalability of our application. NoSQL is a database type that is very much different from the concept of RDBMS or OutDBMS. The main difference itself is that it does not recognize the term relation and does not use the concept of schema. In NoSQL, each table stands alone independent of other table. NoSQL database is a database of type NoSQL. This database is not familiar with the term relational and does not use the concept of schema. Examples of NoSQL database are MongoDB. The second topic, types of NoSQL database. Several different varieties of NoSQL database have been created to support specific needs and use case. These fall into four main categories. 1. Key value data store. 2. Document stores. 3. Wide column stores. 4. Drop stores. Multimodal database reference some combination of the four types described above and therefore can support a wider range of application. The last topic, benefits of NoSQL. NoSQL database offer enterprise important advantage for traditional RDBMS, including 1. Scalability, 2. Performance, 3. High availability, 4. Global availability, 5. Flexible data modeling. Okay, enough for my part, which is also the last part of our explanation.
So guys, that was the end of our discussions about cloud computing. That was really an interesting topic, right?
Yeah, of course.
And thank you guys for watch and listen to our lesson.
And we hope our video is interesting enough for you and useful for you who are watching and listening. And
Don't forget to leave, comment, like, subscribe to our channel.
Okay guys, bye. Thank you.
On fundamental issues, record to realize large-scale computing together.
Itu baik tingkah tahu aku baru kesel banget.
Aku udah bayar pindah belum?
Belum, nanti kita ngetek dulu.
and
Diam.